today, but wanted to. I'm curious how the how testnet went this morning. Did you attend?
Tomislav and I did.
Oh,
It was kind of in and out. I didn't pay full attention. What did you think?
I was only a listener, so yeah. I'm glad to hear that the whole network was working for a full week without restart.
Me too.
So yeah.
Yeah, I was really encouraged by that. I'm wanting to get the cryptographic signing and hashing in my wallet so I can connect up to test wallet. That's they have testnet, so that's the main thing that's been distracting me, I guess you could say, or blocking me from getting that connected. So one of the things I wanted to just mention here today, Joshy, was I'm pretty much resolved on the way to get data, and the pattern to get data back to the client. So that might be interesting to go over. I don't know what others have to talk about.
Yeah, what do you guys think? I wanted to show I kicked around this idea of a way to spawn a bunch of processes in rholang a couple weeks ago, and I finally got around to starting it this morning, and I think it won't be too many lines of code, so I might show that after you do yours.
Oh, cool. Mine's pretty brief. Yeah.
Okay. Yeah. Any other agenda items before Ed takes over? Okay. Yeah, go for it.
Well, so yeah, Jim, I'll come off the camera for your benefit. Yeah, just we had talked a week and a half or maybe two ago about hi Gary.
Hi Gary.
We had talked about a pattern where as a DApp, when you deploy rholang and wanting to listen for the channel when you come back, how that would work from, if you have lots of rholang you're deploying as a DApp, how can that be as consistent as possible to parse it and so forth? And I kind of concluded that, everyone is going to be a bit unique, and whether you're listening on, one channel that originally I was thinking, I'd want to listen on, one unique channel per deploy, and then get a set of strings back. And always maybe the first string or Boolean would be true or false, and then the rest would be what else you need. But that I think is too limiting. Is sometimes you might want a blob back or a byte array, or sometimes you might want an integer or double back or whatever. So I really think it's going to be per rholang what you want back. I think it is helpful to get it all back at once on one channel, but not necessarily. But that's what I chose to do. And the trick is just writing a parser, for the rholang you deploy. And I've kind of come to peace with that. I may be able in Scala.js to genericize it, if you will. I can take a minute if you like and show you an example of the parsing that one has to do.
Yeah, great.
Yeah,
from a client perspective. Let's. I haven't warmed up the app this morning, so we'll see what it's behaving like today.
Whenever I buy a vehicle, I make the person show me a cold start so I know how it works when it's not already warmed up. So that's what I get to do today.
That's a good way to do it. Well, this will be pretty cold start. So again, this is on running against my local host with Envoy proxy in the middle. This is 0.9.1. I've prettied up the UI a little bit to show some things. Let's see.
Yeah, it looks nice. What are the bars at the top below? Oh, is that your JavaScript debugging tool?
Oh yeah, I see. I put it on responsive UI. I'm going to take this off of responsive UI so you can a little more gigantic. So this is not a fresh UI. So I think all of these have Genesis already of some form. So or a faucet of some form. So this is saying the balance is 196. It shows it twice for whatever reason. And then okay, so it timed out, and I think the reason it timed out has something to do with the state of our chain. So I'm gonna go up to I'm going to wipe out our node and restart it. This is just a state that it gets in. I think this was one of them that they have since discovered. So luckily, I do this all the time. Yeah, I'm really looking forward to knowing which of the issues I'm running into, which some I don't know whether it's my code or the node or the way I'm using the node are going to go away when I connect up with what's now 093. I'm really looking forward to that.
Yeah, that's great. Yeah, it's nice when some of your bugs turn out to be in other people's code and just magically get fixed.
I'm hoping. Okay, so yeah, so connecting up with localhost is just not ready yet. Beginning approved block. I haven't seen sort of the magic.
And once this whole network is stable, like this waiting time will not exist because the network will just already be running.
Correct. Yeah, there it is. Making approved transition. All right. So now we can get some rev for what I'm calling Gene. So this is ultimately getting back an integer. I don't know if I'm getting it back as a string. I can transfer from Gene, who has 9,000 test rev, to, let's say, Alice. And so these happen to be pretty similar. They're getting the same shape back. So I'm parsing them in a similar way. And what I do when I hit a button, I bring it down into this test row so I can actually see what was sent and show you how it comes back.
So what's in that little row window? This is what you deployed when you clicked the button?
Exactly. So it's what I deployed in the previous time, and then what I do is I set a new unique channel when I hit this test row. So I used a regex expression to replace it with a new channel. And so here's what I get back. And so this gbool true, where my cursor is, if you can see it, is what I need to parse for. But let's say I get a false back. So let's say so Gene should now have 8,900. So if I prepare for transferring, let's say, more than that back, 8,800. That's interesting. Let's say attempt to transfer 9,000. That should fail. And the shape of the fail might or might not be different. I don't remember if it's a simple Boolean. Oh, insufficient funds. So I'm actually getting back a reason why it failed. So now I'm going to do the same test row so you can see what that structure looks on coming back. And this is actually, although it's my rholang, it's bubbling up from the vault contract. So I have to essentially deal with what's coming back from the. So here you see gbool false, and then a bunch of parsing, and then you see gstring insufficient funds. So the you know, vault and contracts will have this kind of pattern of true and false, and then a string to the right, I believe. But I can't always rely on that for some other contracts. Like for example, I doubt if our songs returns look anything like that. If I ever wanted to interact with those contracts, or anyone else. So the parsing of this, I find to be a big challenge, but you can work through it. It's just after having to deal with that. So.
But are you saying that you are parsing this as a string or as some kind of structure that you
as
get
a structure in my case? Let's see, where's this at?
So in a sense, you're really making a transformation, right? It's not exactly parsing string, and
It's in my case, it's getting back a protobuf expression, I think, and it is pretty strongly typed for me.
Okay, yeah. Yeah, but it's deeply nested, and this is why it's difficult to handle.
Yeah. So let me find the right place. Test row. So this is this method I talked about maybe last Saturday during Dan's office hour times, where I'm doing a deploy, a propose, and then a listen. I'm actually not doing the parse in this function. I'm pulled it out, so it's kind of a misnomer now. And then I'm checking the results from it. Here in the case of this just test row, on the good case, I'm just showing the block results as a string. But elsewhere, let's see. Let me go up one. I'm having to do quite an expression here to parse.
Oh my goodness.
Sorry?
Just, oh my goodness, that's just such a long.
Yeah, so I don't know if I'm doing this the most, generic, implicit, best way, but it works. And you can kind of, read what's coming back, and then for me, I start getting used to writing these things after a while. And there's, of course, with me, there's some trial and error, but I get through it. So I forget, this was when, in the case where there's a string coming back for transfer funds. So my contract or rholang for it, which is right up here, it's getting so this looks very similar to the example that was sent. So on the result channel, it's getting back a result. This was in the demo of how it logs it to standard out, and I'm just forwarding on the result to this what I'm calling per deployment return channel, and that's what I was parsing below. It happens to be coming back as a string here as opposed to a Boolean. I think I'm a little confused by what I'm seeing here. Maybe oh, there it is. No, it is a Boolean. Let's see, that's if its fault is right. Oh, that's if, oh, I see. Even, okay, this is based on the expression coming back from this insufficient funds thing. So the underlying contract, I guess it's a user's vault, has the expression of, the true or false, and then the right side may be a string of that. It's this.
Yeah,
the
yes.
type is a co-op.rchain.ether.ether, if that helps.
So yeah, this tuple body, you're using the first element, which is Boolean, and this head, right? And if you select the second one, it will be a string.
Yes. So yeah, if it's false, then if it's true, I don't care to present back to the user, why it was true, and there may not be anything there. But if it was false, I need to tell the user why. It's in this case insufficient funds, but there might be other reasons why that come back as well. So that's my show and tell.
Oh, cool.
I'll just for fun, I'll put in those couple of things into the chat.
Yeah, that's a good idea. And so I think, Ed, I was noticing like those the first of those lines you just had highlighted, the first and last one, they're those super long expressions that help you drill down into the data structure. And they start out almost the same. Like the first half of them, I think, is the same.
Yes.
And that's the part that gets you just down to that tuple. And then they diverge, whether you want to look at like the first element in the tuple or the second element.
Yes. And those are unique per contract, is my point.
Yeah. So I think you might be able to, as you sort of like, write more of these or flesh out your app more, start to notice like, oh, I'm doing these first 6, thing, dot, thing, dot, thing always seem the same. Maybe I could abstract those out. And then they'll be, I don't know, if you or whoever ends up doing that enough, we might end up with a library of like, given an arbitrary process, converted into just a tuple. I know it's supposed to be a tuple or something like that. But yeah, I think sort of like the bottom line is somewhere you have to dig through that whole data structure, whether it's like nicely compartmentalized or sort of all in one big expression. It has to happen somewhere.
Right. And of course, in this result is, or maybe it's not obvious, is also a lot of the block data that, when was the block, what's the block timestamp and what's the block height, and I don't know what else is there. I don't look at it, but it comes back to.
Yeah.
Cool. Thanks for watching.
Awesome. Yeah. Well, thanks for sharing. That's some pretty nice progress you've got going there. That wallet's looking good.
Yeah, I looked at the RSong Kayvon's code, and he does this in a lot more generic type of way with Scala traits, and it's beautiful. I just hammer it through. It's elegant.
Yeah. Nice.
Yeah.
Cool.
Yeah, that's great. That's great. So what are your plans for the wallet then? I guess it's sometime soon is going to be putting in the signature stuff, and then.
Yeah, actively working on that now. So I'm having to pull in, JavaScript libraries for Blake 2 hashing and for ED 25519, and I think I need another library for, I don't know if it's there was another hashing, I think Blake, I forget what it is.
Yeah.
Anyway, so then, the ability to, construct the rev addresses and to cryptographically sign, then I'll connect up with testnet, then I'll host it on AWS and start getting a lot of community feedback and allowing, everyone to start hitting testnet and the wallet code as well. So that I think will be very exciting.
That is going to be exciting. Yeah, I feel like you're super close.
Yeah, and then fundraising. Yeah.
Good.
Yeah, it feels good.
Yeah, cool. Yeah, that interface is way nicer than like what Nutzipper was showing in the note. Like it does the same things, but his is all shell scripts and pasting the keys into the right spots. I mean, I guess you always have to paste keys to some extent, but like the UI makes it really nice. I think people will play with testnet a lot more if they can use an interface.
Yeah. And the great thing is you can just keep clicking the button and slam testnet, which is exactly what we want.
Yeah.
But so it's easy to try different things and see where it fails. And there's some things going on. One of the issues, I don't know whether it's my code or the node, for example, is if you do a transfer and then check balance, turns out they both fail. I think it's in my code, but it might be in the node. So that's an example of that I really look forward to working through, and it may have been solved in 09.3. So
yeah, that'd be great. Well, I have a little bit of rholang code that I had started that we can look at, but definitely if anybody else wants to show anything or ask anything, that can go first. What are you guys thinking?
I have some progress on additional names that I created. So.
Oh yeah.
Yeah, maybe I can show later. I have like one example to show.
Okay, all right. Well, maybe I'll do this snippet and then we'll go to yours. I don't think mine will be more than a few minutes, but you know how it goes. You can never be sure.
Yeah. And I'm also interested in this example that you wrote on Discord.
That I wrote on Discord?
Yeah. I'm a little confused. How you get comms in your
oh, it's a bug. It's definitely a bug. I know. I didn't know what you were talking about at first, but now I think I do. This one, right?
Yeah.
Well, my first question is, what the heck did I do wrong with Robot? Why didn't it run my code?
But I'm not sure if this is the exactly code that gets the code. You know, maybe someone else.
The same one, and it ran for him.
Yeah. So I'm a little confused.
I had to restart the server.
The node might have crashed or something.
The node was fine.
Oh.
I haven't been able to diagnose it, but like once every week or a couple weeks, the server just complains that it can't connect or something.
Oh, you're talking about like Robot itself, like the middleware that talks to the node.
Robot.
Yeah. Oh, okay, cool. So maybe that's what went wrong here. Yeah, I think this is a bug. I mean, so the basic structure is at some channel, I sent nil, and then I listened on some different channel, but it came through and got a comm. So I don't think that's like intentional behavior, or if it is, I sure don't understand why or how it works.
Yeah, but did you try this on a fresh instance of your node?
That's where I discovered it, yeah. Maybe we should do that first, actually.
Yeah, I on my node, this not produce a comm. So yeah.
Let's just save it real quick.
Can you paste this in the chat?
Oh yeah, totally. Or what if I paste it? Or it's over here, Ed.
Got it. I'll go to Colab rholang. Okay.
Okay, cool, perfect.
And why are you using bind that is like not linear?
I don't know why I did that. I don't think that was necessary, but that's a good question. I wonder, it would be super trippy if that's what messed up the, like why we got a comm and the regular bind didn't.
Yeah, but yeah, this doesn't make sense.
Okay. I should have done this part first. That'll take some time to come up.
But you are running this on fresh node, right? You have deleted the other folder.
Now I am.
Cool. Just checking. I want to be sure.
Yeah, good idea. You can't be too careful.
Because I was.
That actually is a huge problem because I might have had stuff in the tuple space that it was actually comming with from before. I did not think about that.
Yeah, exactly. I ended up with an example like that.
Yeah.
Because this is like a fixed name, right? As any number or string.
Yeah, that's a public name, a forgeable name.
Yeah, exactly.
Yeah. Oh, and in fact, that's definitely another reason why this should be a regular linear bind, because then if we do get a comm, this won't be kicking around in the tuple space in the future.
Yeah.
So that really might have been a bug. I'm glad we're looking into this. I might have an issue to close in Atlassian. Okay, let's see here. Oh, there we go. Okay, so I think we're good to go now.
Yep.
Oh, and I should have made it a linear bind right now, but we'll see. So that time I did not get a comm. Okay. So that's interesting. Yeah, I think I might have. I think I might have actually been confusing myself with a stale tuple space.
Yeah, this is possible.
So it seems like this doesn't calm.
And in Jim's example on Discord, maybe there is some kind of leftover send.
Yeah.
But why your example didn't? But this, yeah.
Well, Jim was saying he thinks maybe this one never made it to the node because of a problem with robot.
Oh.
And
Nice.
then once he did it again and it did run, now we have a hypothesis that this came from something else that was left over in the tuple space.
Yeah, when I run this on 091, I get a cannot find instance of name on the listen. When I put a public name in there and listen for it, I cannot find an instance of the name. So essentially, I think that means I don't get a com.
Wait, what was that, Ed? You ran this code?
Yeah, so instead of standard out, I put in one of my special channels.
Oh, yeah, totally. And then you listen for it through gRPC.
Yeah, and I cannot find instance of name, which is what I would expect. In other words, no com.
Yeah, I agree.
I have a dumb question, Joshy.
Yeah, sure.
So on these, once you push something on a public name, how long does it stay around? Forever?
Until you consume it. Yeah.
Well, but if I see, but in your case, your example, you thought you had something laying around, and so essentially you did consume it. So if you ran that twice in a row, would it?
These ones here, like this code, you mean?
Yeah. So
this is an example of a send on a public name. So I've sent 2 of those now. So they're both still in the tuple space.
Uh-huh.
They're both still chilling there. In fact, we can dig them up right now.
Yeah. And you can comment out the current send.
Yeah, that's right.
Because you get.
Oh, I see. You mean you're sort of ahead of yourself on consumption, or?
Yeah. So I sent, each time I did this, I've done it twice now. Each time I did it, I sent a send and a receive. And the first time the receive was a little bit, it was the persistent one, which makes this even a little more complicated. But the sends are not. The sends were just both linear sends. And so they're both still sitting there in the tuple space. And so if I just get rid of all of this stuff now, then this should, in fact, maybe I'll just do this.
Well, it doesn't know what X is, though. Oh, it says new X. Okay.
Yeah.
It doesn't know what pointer X is. Let's see.
Oh, yeah, that's good enough.
Yeah.
So we should see that deploying just this part actually does com with one of these that's left over from before when I run it.
Okay, got it.
Is that what everybody is expecting, or am I missing anything?
Yeah, exactly.
Well, let's see it.
What was that, Jim?
I think that's backwards. If you do just the top part, it'll get gotta com again. I just did it in robot.
I think the problem with robot is exactly what we're describing, which is that before I came up with this clever bit of code, I had done a bunch of other similar tests, and pieces of them are still lingering around in the tuple space, confusing what we're doing here.
Oh yeah, I agree. I mean,
yeah.
That's why running that first line again. If you do a persistent for,
yeah,
keep getting gotta com every time.
Yeah. I see what you're saying. Like maybe we can just do this part in robot.
Look at Discord.
Oh, you did it already. Oh, yeah. Oh, so you're confirming exactly what we're thinking, right?
Right.
Yeah.
So now I'm a little confused about is there one X, or is that because it's a public name, or are you continuing to listen? Is it treated sort of like a buffer? When you listen to X, do you get all of the X's back?
Well, one interesting subtlety is that we're not ever actually using the channel X here. We've never sent or received anything on X. The channel that we're using is this whole thing. Because remember, a channel is just a quoted process, and new X in whatever is a valid process.
Ah, I see.
Yeah, and
And
so like Tomislav was saying, anyone can write down this process just by typing the characters I've highlighted, which means it's a public name. So just like at quote, whatever, my
I
channel.
see. I
Yeah.
see.
and it is also possible that
If you run that same eval again, you won't get a com next time, will you?
Yes, we will.
I think we will. I think Jim's going to do it right now. And I think what we're concluding is that somewhere before I started, talking about all of this stuff, I put something in the tuple space that persistently listens on this channel.
Oh, that was you mean
Yeah. Okay.
persistently sends to that channel?
Well, Jim is doing the sends one at a time right now.
Yeah.
So the other half I must have deployed earlier is the persistent listen.
Right, and I deployed it again, so we
Yeah.
right up above.
Okay, I'm trying to reconcile this with the statement you made earlier, which is when you have a com event, when you listen on it, that com is done, and you are it's no longer there. It's consumed. Am I misunderstanding?
If
So-
you look up a little, you'll see where I sent separately the persistent listen. Right there.
Yeah.
Okay, so I'm persistently listening. Oh,
But
Yeah,
Jim, this is not the
This
one.
is what we're coming with, though. This is a different thing that's sitting there not being part of these comms that you're doing down below.
right.
But there's somewhere, I bet if we scroll back a few days, there's something that looks a lot like this, but instead of listening on this channel, it listens on this channel.
Yeah, exactly.
That's my thought. I wonder if it's worth digging back in here.
But
And in Joshy's example, that he ran now, he made a send and receive which are not sending on the same and receiving on the same channel. So there is now a send and receive in tuple space that are just are floating around.
Yeah.
Right.
I think this is the one that we're coming with. I put this in here at the very beginning when I started playing.
Cool.
and remind me what again makes it persistent?
The equal sign instead of the dash.
Ah,
Yeah. The double arrow is persistent and the single arrow is just a normal linear listen. Yeah. Okay, so let's go back to here and try to summarize. So the stuff in Discord can be confusing because there's stuff that we've done days before, like before this call, or maybe that people didn't even see come across the Discord. But you guys have seen everything I've done on my local node here. So we actually have a good sense of what's in the tuple space on my local node. So right now, we've got two of these things, and we've got one of these things, and we've also got one of these things that's persistent in the tuple space. And that's it. Those four, and the hash functions and the standard out and the stuff that comes with the node. But that's the complete state of the tuple space on my node. So my hypothesis now is if I run this code, we'll get a com. In fact, I'm going to change the message just to be sure we know which one it is. I think if we run the code, we'll get a com the first time, and we'll get a com the second time. That'll take care of both of these. But then the third time, there shouldn't be a com because we'll be out of the sends.
Yep.
And I made sure not to accidentally do a persistent listen this time. So let's try it. Okay, cool. So there's the nice long message. There's the nice long message. And this time I'm expecting no com because we've consumed all the sends.
Yeah.
Nice.
Yeah. And this is the reason why I was using a number in par. If you remember in my example,
Oh.
I wanted to have like something that is unique and for each go a little up.
But yeah, I'm following Tomislav. But in most cases, use cases, you don't need a persistent send, right? Or I guess it all depends what you're doing. If you're listening to our song music, you want a persistent send. But if you are just checking your balance, you want a temporary, perhaps.
Yeah, I think one of the biggest problems is that when I started this thing, I don't think it was even intentional, but somehow I put a persistent listen here, and that's what got me all confused in the first place. Yeah. Yeah, okay, cool. So before we forget, I want to close that. Or I don't even know if I can close it, actually. I don't know. I'll leave it to the right people. Okay. Should we? What other things should we talk about here? Or do you want to switch to my spawn N?
Well, for me, in my last example, if you are sending on for, you can do it like in both ways. You can say for at X and then use this as a processor. Also, in a different way, you can say this is a name and then evaluate it as process.
You're talking about this one?
No, not this one. I think this is the last one.
This one.
Yeah, exactly.
Oh, this is your channel here.
Yeah.
4x.
But it's not really the same, right? Because X is a name and Y is a process. But you get the call. So they are really the same. But this doesn't exist in raw calculus, right? It's only existing in rholang.
This doesn't exist at all in row calculus, right? This pattern matching and getting X to be the underlying process?
Yeah. I'm not sure completely, but they are the same, but it's not completely the same, right? So
in row, you have to, like, you don't get to bind variables in row calc, right? You just get to say, like, whatever this name is that was here. Well, yeah, go ahead.
Yeah, you're right. You're saying that this is like a matching on variable inside the for, but yeah, this doesn't exist in local.
This was a really cool example. I didn't even remember this one just now. It's interesting how subtle it is. Yeah, with whether you're doing the dropping here by pattern matching or here by explicitly dropping. Yeah, I like that.
I'm really interested how this will work in Roxy.
I would probably give a bunch of error messages right now. Yeah, we can look at Roxy a little bit too. I made some good progress on her on Tuesday, but not since.
Yeah, now you can write a code, right?
You can write some code. Obviously, the one that I showed you guys is the one that works. There's lots of other ones that don't work yet.
Yeah, but this is cool.
Yeah.
Are you doing patterns in Roxy yet?
Not in any serious way. The only patterns that I support right now are the wildcard, like the underscore, and variables that just bind anything. Patterns will come. They're planned, but I haven't really done much of it yet.
This means that you have only one binding, right? Now you want to have multiple binding, right?
That's right. Yeah.
And how, when you think about that, how big the change is to make only one variable to multiple variables? I'm just interested.
I don't think it's that big. Let's take a look. So my pattern matcher is here. And it's just this one function, pattern match, and it takes in a pattern and a process. And it returns either false, which means they did not match. Wait, am I describing the right thing here?
So
what did my code say? Oh yeah, that's right.
yeah, this makes sense.
But I don't see the spot where I actually returned false. That doesn't seem right. Oh, that's because these ones always match. I don't have any cases where I return false yet. These wildcard pattern matches anything, and variable pattern also matches anything.
And is it the same when you return empty map and false?
No, it's not. Empty map means the pattern matched but did not produce any bindings.
Oh, this will always match, and yeah, with false you want to say, okay, I cannot match this.
Didn't match at all. Yeah. Exactly. So other things would be.
Oh, but here for variable, you already have a map, right? You can now return multiple bindings. You have a map, right? Not only
totally. Returning multiple bindings will not be a problem. That part I do have.
Cool.
Don't have any cases that actually do it yet.
I remember from last time that you talked about it.
Yeah, this hasn't changed at all since we talked about it last time.
But now you only need like a better matching and
more cases. That's all it takes. Yeah. And it'll be recursive too, because like when we do a tuple, for example, if the arities are different, return false. That's it, easy. And then just if the arities are the same, then we recurse like, you know, the first spot in the pattern, first spot in the process, and then likewise as we move across.
And you populate the map with each variable that is free, right? You're searching for free variables. Am I correct?
You're searching for all the variables that appear in binding positions in the patterns, basically.
But this means that name is, this name must be free in pattern expression, right?
In the pattern expression.
Because if it is not free, if it is bound in this scope, you should only allow it with equality sign, right? Because you're referencing something that already exists, so you will just check if this is the same. Okay, I'm pattern matcher.
All of that happens before we get to this function.
I see.
So before we get here, so pattern comes in, let's just imagine I have a tuple pattern. And so you could imagine a tuple pattern that looks something like this. Like that should match any 3 tuple and bind all of X, Y, and Z, right?
Yeah.
But you could also imagine that I wrote a pattern that looks like this.
Exactly.
Now that means it's going to match any 3 tuple where the third item is the same as whatever I bound to Z previously, and X and Y will bind to new stuff. So something like this will never be passed in for pattern as the pattern matcher, because before we get here, previously on Roxy, this pattern would have turned into something like X, Y, 4, or whatever Z is. The Z would have already been evaluated and replaced with whatever concrete process Z was bound to.
Oh, I see.
Yeah. Cool, so that does have to happen, but not inside the pattern matcher itself.
Okay. No, I just wanted to ask you where you look for Z, but you don't have to look for Z because it's already like
well, it's still an interesting question. It's just not a relevant one for this particular portion of Roxy. Cool. And we talked at some point about how every receive that's in the tuple space has an environment attached to it, which is basically just like a list of all the variables that are already bound there. And so that's where I would look up Z. Like when I'm about to do a pattern match, I would first evaluate the pattern in that environment and then pass it in here to pattern match.
Yeah, so you don't have to have environment here.
Yeah, that's right. Cool. That's right. And also, so I haven't implemented this yet, but my thought is that this is basically all in the parser. When because the parser will see these X and Y, and because they're in a pattern, it knows that this is supposed to be like a variable pattern. This one, when it sees equals Z, what it puts into the abstract syntax tree is not a variable pattern. It's just a regular old variable mention, like any other variable mention that will get evaluated in the environment the same way.
Wow. So you're sorry.
This may be off topic. Gary was asking about the space calculus in rholang possibility, and I was thinking about, in order for a process to change location, it would, as I understand it, it would require that you modify this local namespace, of bound names to the process, and I guess there's no way to do that in rholang. We can't pass a parameter to some process.
You're talking about a K, which pairs with P, right? Like a context with the process. Yeah, and I was listening again Greg's lecture, and he was talking about, I mentioned that K flows through context, but this is not the case. The P is moving through space, and Greg was saying that K is a context which is now is not available in surface language, right? But in his example of space-time calculus, the K is available in the language. So this is your context, right?
Okay.
So you can modify this context, but I'm not sure from where K is coming.
What's the difference between the context and the bound names?
Sorry, what?
What's the difference between a context and a bound name?
And the bound names. Bound names gives it context, right?
Yeah, this is true, definitely.
Yeah,
Right.
so the set of bound names and what they're bound to is what I've been referring to as an environment. I don't think that's the same as the context here, but I don't clearly understand this. Well, yeah, in fact, I'm sure it's different because this context is like these processes, right? Like you can have one hold process, or you can have like at somewhere send nil or whatever. Well, I guess I can put p, or you could do like at p send one of those. So these, I think it's just although the word context can mean both of those things, I think this context is different from the set of bindings.
Yeah, but Greg mentioned that Greg was answering on someone's question that this context, in a sense, is it's part of this context that we already have, but it's like extended.
Oh wow, that was in the lectures from like last year.
Yeah.
Oh wow, okay. Yeah, I got to work through more of those still, I think.
Definitely is not the same, but they have connection, because Greg was mentioning that labeling transitions is also similar to this context, right?
And
Yeah, I don't know. That's not very fresh for me. Yeah. So, what was that, Jim?
In thinking about a process in a space of processes, in order for it to change location, the connections would change. And the only way that connections are manifest are in the bindings, right?
Connections.
Seem to be related.
What do you mean by connections?
Like shared scope, like I know this same name that some other process knows, and so we kind of have like a communication channel between us.
Right.
Yeah, what does it mean to change? What does location update mean? I'm not really clear on that.
Well, the proximity is how many steps there are between here and there, right? That's how I understand it.
Okay. Yeah. Are you looking for something to share, Tomislav?
Yeah. I wrote some stuff that Greg was mentioning in his lectures. I will paste this in chat. Where is my chat? He was explaining what is the space.
A context P pair is describing a location. We're now describing how P moves in space, where the space is given by the term which is the composition of K with P. P is moving through a range of different contexts. Oh, this is like when he was talking about converting between protocols.
Yeah, exactly. And he's mentioning this dynamism, what also Gary was mentioning.
Did you say diamond?
The dynamism, the dynamic.
Oh.
I don't have everything about that. I found this sentence.
Is this your notes?
Yeah. I didn't finish all the notes, so I will post it in the Discord.
Nice.
Tomislav, what is that you have down there? I mean, where did that come from? Did you come up with that, or is that you quoted Greg there?
Yeah. This is from his lectures about calculation properly. I can post.
Yeah, I would like to tie that quote with a given lecture, if possible.
Here is the exactly lecture, the exact time.
Okay, thanks.
Where it's starting to. Yeah, I will post this on Discord, but I didn't finish. So
yeah,
I'll
definitely look at that, because that answers the question I was asking, I think.
Yeah. I was exactly. This is the reason I was watching again, because you're asking the interesting question.
Thank you. Yeah, they're the ones that are coming up to me as I'm trying to follow him, and I think that answers it. I'm excited about this.
Cool. I'm still not sure where K's come from. This context. Who creates a context? Do we have like something inside the rholang, like another terms that we can create and just make up new context? Or
Well, we can enumerate the contexts in the same way we can enumerate the processes, right? I started to do it a second ago. You just write out all the processes and knock holes in them wherever it's possible.
So you just create a K and say, okay, com K, and you are creating the case, right? You're putting it in the
I think so. Again, let me be clear. I'm just kind of like thinking out loud, but that's my working understanding, is that we can do that.
Yeah, I'm thinking the same. Yeah.
Looking at rholang, a context is defined by curly braces. Okay, that
I don't think that's the same context we're talking about here. Like, so Jim, you're talking, when you say curly braces, you're talking about like, 4x from y, open curly brace, and then a bunch of junk, and then close curly brace, right?
all right.
I think that's different than the K's that he's talking about here. Right or no?
Well, I would say they have to be related. Maybe.
Okay.
I mean, the process between the curly braces is not the context.
Okay.
Okay. What really the names that are available to it are the context.
Hmm. Oh. Yeah.
And it's not as simple as just the. I mean, that's why I was relating it to this list of names that you have associated with each context, so to speak. But of course, public names muddy the waters in that they. Well, they're in a global context, so I guess that doesn't really affect anything much.
Yeah.
But in this calculus, names and context are two different things, right? So there is this recursive relation, right? Because now we have two different reductions that can happen. Reductions with context that creates a com, and the normal reduction that is send receive. I'm not completely sure how another reduction works.
Wait. You're saying
where this another? Yeah.
You're saying there's another reduction other than this new version of the com rule?
Yeah. So
I thought my understanding was that rather so in normal old row calculus, there's one way to reduce it. It's com, right? And then in this space-time calculus, or maybe just space calculus, then there's there's now infinitely many com rules, but the only reason there's so many is because there's one for each context, and they basically all work the same way, which is where the substitution is like, instead of just jamming P in for the name, you first put it into, you put like K of P. So, I see. Okay, so reductions.
So K is a process.
You're right.
K is another object.
Yeah,
like
K is a
process and name. Yeah.
It's not a process, or it is a process?
It's not a process. They're similar, sort of, but they're
yeah.
So like in row calc, we have two sort of like two kinds of things in our universe, names and processes. And now here we have three sorts of things. We have processes, which are basically the same as always with a couple new constructors. Contexts, which are brand new, but in some ways like processes. And then finally names, which are sorted like before, but rather than just being quotes of processes, now names are quotes of pairs. To make a name, you need a context and a process. And when you quote that pair, you get a name.
Yeah.
So a namespace so it's not a process and it's not a namespace, but it's like a namespace.
The contexts are a lot like processes, but they're just a little. So do you guys want to try to write out the grammar and maybe try to even do an example reduction or something? I feel like that's the stage that I'm at.
Yeah.
So let's start
Something
with
that Isaac mentioned last time. He was explaining, right?
Yeah. That was when I started to finally feel confident that like maybe we could do some of this. So here's the reductions. I just copy pasted that from yours. So first we can do this, right? So there's some of these are the same as always.
Oh, I can paste you the whole
Oh
thing.
yeah, okay, cool.
Yeah. So here is everything from this page.
Okay. So these are all the different ways we can make processes. Wait, this is not one of them. These are all the ways we can make processes. So we've got most of these the same. We've got our receive process, we've got our send process, we've got par, we've got drop. We've got two new ones. So we've got this is a new one and this is a new one, right?
Yep.
And this is the same as how we normally write nil. And then, okay.
There's a missing equals on P and Q. On line third, on line 3. Missing equal sign.
Oh, thanks. How did I do that? Yeah.
I think. Yeah.
All right. So here's all our. What was that?
It's my error.
Oh, okay. Oh, cool. I thought maybe I just.
Oh, nice.
Shit. I'm going to spell it with a K just so we can keep it straight because he always uses K for context. So these are almost the same as before with just the two new guys. These are almost the same as before, except instead of just quoting a process, we always quote a context and a process together. So like, so for example, at nil is not a valid name anymore. But something like at the one hold context and nil is a valid name. Does that seem right?
Yeah, totally.
Okay, so let's try some examples. Is this a valid name? At, let's just say, oh wow, okay, at 4 underscore, well, you can't do that here, I guess. 4x from y nil. So what do you think? Is that a valid name?
This is not valid.
Yeah, it's not because this is the sort of old school row calc way of just quoting a process. In order to make it a valid space-time name, we have to put some kind of context over here. So we got to put something in for K. So let's try an easy one. Oh, that's not going to work. What is an easy one?
Yeah, just a hold.
Yeah, that's the easiest one. I feel like I already copped out on the easiest one. How about if we do this? That's
you can send on. How
about that? What was that?
Yeah, you can do
that doesn't work either because I can't send on at nil.
Yeah, you must have another something. Yeah, this is a little confusing. And also the nil process in 4. You cannot have just a nil. You must have again.
No, here I can. This is just the 4 is just a process.
Oh yeah. Right. Oh right. Oh cool.
Okay, so let's use syntax highlighting to our advantage here. Whoops. Whoa. Are these even lined up?
What you're trying to do?
I don't know what I'm trying to do. That's a good question. I was trying to make, you know how JSON always indents and looks all beautiful and easy to read? I thought maybe I could do that.
Oh.
So I was basically trying to say, oh, we're trying to make a valid name, right? This is a name. And so I wanted to say, in order to be a name, it starts with an at angle and ends with an at angle. So then the question is, what's the thing that we're quoting? And it needs a comma. I don't know. This
So,
is not making it easier to read, is it?
yeah.
Maybe if I do it like this. Part of the thing is I'm not convinced that I actually have a valid name yet. So in order to make a valid name, I need two things. I need to quote two things. I need to quote a context and a process. So is this a context?
Is this a valid context?
It is a context. It's a send with a hole knocked in it.
But you're making a name and not context. You're saying at something, but you want to have context and not a name, right?
Because names are themselves.
But you want K and not X or Y.
This whole thing is a K. You can tell because it has a hole in it.
But but you're saying at something, so it cannot be K. It must be a name because at is a constructor for name.
This part's a name. At whole comma nil is a name. And then I used that name in this constructor as this X. So this thing right here is this X.
Oh,
and then this
but
bound.
not in P, but in K, right? Not in P. You're using the construct in K. Send on the K terms in line 26.
36? 26?
26.
This
You're
one?
using yeah, because you're using this send, right? That you construct a K.
This one. Is that what you mean?
Yeah, exactly.
Yeah, that's right. So this context right here is one of these. So we only have to sub in for X and K. So what I subbed in for K was a single hole.
I see.
What I subbed in for X was this whole thing.
Yeah, this makes sense. Yeah, totally.
Oh, yeah, you're right. This is what I should have been pointing at, not this one up here, because this was for a process. Yeah, you're right.
Yep.
And then this is just a normal process. That's the simplest thing we've got today. That's just a receive process.
Cool. Yeah, you're right.
What I didn't anticipate was having to nest these so deeply. I feel like already this was a helpful example. So, okay, so now that we've done, so this is close to what I was trying to do, where you have like the beginning of the quote, the comma, and the end of the quote all clearly identified. And then what I wanted to do before I got myself confused was do the same thing but nested once.
I see.
And I think it's supposed to look like that or something,
Yeah.
but I'm not saying it's helpful.
Yeah.
I thought it might be helpful.
Yeah. It looks nice. Yeah. There are two tuples, right?
Yeah, that's right. That's right. Wow. So finally we got one of those things. I was going to try to come up with a reduction.
Yeah.
Well, here's our oh, a simple calculation shows. What is all this stuff about? Oh, this is a reduction rule. You're going to show me that this.
This is example.
Cool. Oh, let's go through it.
Yep.
Okay, so this is basically a process with 4 terms in it. We've got 3 terms in it. So here's one of them. Here's one of them, and here's the third.
Yep.
So we want to reduce this. So we gotta look for we basically have 2 reduction rules that you showed us. They're these. And so we have to say, does this reduction rule apply? And does this reduction rule apply? It looks to me like this one does not, because I don't even see any, wait, where's our example?
Yeah.
I don't even see any U's in there. So I think this reduction does not apply.
Yeah, this is not in this example, yeah.
This one looks like it might, because we have a com K, that's at the end. We have a receive, that's at the beginning. And we have a send, and that's here.
Yep, exactly.
So the reduction rule says, you take the thing that you're sending and you sub in
So this K, K will be semantically substitute. I'm not sure what does it mean semantically substitute, but and this will happen in line 40, right? When this P and K replacing the term, and you end up to have K. You're running P with the context K prime.
Okay, I think I get that. I want to rewrite it so it's nice and easy. Let's do a space calc reduction. So here it is. This way I won't accidentally mess up his correct one if we screw it up. And I want to write it this way. So we've got 3 terms there. So it's not that different from before, right? We've got to receive, we've got to send. We're ultimately going to substitute the thing we sent in for the continuation because they're on the same channel. This is the simplest channel, like we talked about before. But the one rule is, instead of just reducing to simply P, we have to reduce to, we have to put K through this context.
But before we are starting to reduce, we must substitute not only P that we are sending to receive, right? We must substitute and this context K prime.
Yeah.
I'm not sure if this is this semantic substitution. Or
okay, so here's the result. So we want to basically replace. Well, okay, look. So we're saying for @KQ from this channel, and so then we're going to replace all occurrences of @KQ with K prime of P. Does that sound right or no?
Yeah.
Okay, cool. So we keep the star, and then we're going to replace the only one @KQ with, in row calc, it would have just been P. We would have just had something like that. But it's going to be a little bit different because of this com thing. So we do K prime of P. Am I done? What was the right answer? Oh, yeah, totally.
Yeah.
No, what's up with the star?
Yeah.
Oh, that goes away as part of the substitution in the same way that it always does in row calc, I think.
Oh, it's just the process is executing, right?
Yeah.
You're just dropping and running the process.
Okay. All right. So do you think we can do another one?
Oh yeah. Do you have something in mind?
Well, I'm just going to make one up as we go, and it'll either be a good one or it'll be a bad one, and we'll learn why it's a bad one.
Yeah, I like it when Isaac is using variables for this @KQ, but is it helpful or not? I'm not sure.
Yeah. I like it too because it's just so hard. I totally get what he was saying about how terrible it is to write these things manually.
Yeah.
So, oh, in fact, Greg actually did that here too. He gave us a K and a Q instead of writing a manual. Like, this is really not fully concrete, right? Like, we need a K, some actual context and some actual process in there.
Oh, right. This is like a variables, right?
Yeah. Yeah.
Yep.
Okay, so we're gonna replace @KQ with something from.
But we didn't talk about what the K is, right? Is this strange? You know, it's not any K, right? We are searching for some specific K.
I think what matters is that it's the same as this K, whether it's the same as this K.
Oh, I see. Oh, you're sending something on a name, but you're sending something on a not only by a name, but also on the context, right?
Well, the name is the quote of the context in the process. So like, here's the thing that we're sending over. It matches right here. Right, like this name matches this name. That's the same as rhoCalc. In order to have a COM, the channels have to be the same.
Yeah, you're right. The name already contains context there.
Yeah.
This is by the definition. Okay, yeah, this makes sense.
But I don't think it's necessary that this context be the same as this context. I think they can be different. This one we're using as just the channel that we're sending over, and this one we're using as the, like, you know, this is like our bound variable, or like the place we're subbing in for.
Yeah, this is not like something that you are getting from outside, right?
Right, that's right.
Because K is coming from a COM, right?
Yeah, the K that we're ultimately going to use and care about comes from here.
Yeah.
Yeah. So, oh, and in fact, so in this case, it's just a coincidence that I used K and K. Like, I think it's fine that they're the same, but it need not be the case that they're the same.
Yeah.
Okay, cool. So that's pretty interesting. So I guess in that case, then it's not clear to me why we defined names this way. Why are the names quotes of contexts and processes? We haven't yet seen a case where it matters whether this context matches one of these contexts. You know, like, I almost feel like it would work just as well if we just did this.
Yeah, I was wondering, you know, this P is moving through space, but we already have this now, right? You know, P is moving through space.
Yeah, I mean, moving through space still feels a little nebulous to me.
Yeah, to me also.
It's at least moving in the same sense it was moving before.
Yeah.
So,
I'm not
okay.
exactly sure how space is. Why K is important to have this notion of space.
Mm-hmm.
I don't see this connection.
Yeah.
I mean, I understand that there is a recursive relation, but we already have a recursive relation between names and process, right?
Yeah.
Now we have another entity.
Yeah, that's right. And just like processes, so names you can never like create a name out of nowhere. In rhoCalc, you always need a process, and in space calc, you always need a process and a context. But processes and contexts themselves both can be created out of nowhere because we have our ground terms. Like for processes, we have that, and for contexts, we have that one.
Yeah, you're right. So yeah, the context is more similar to process than a name, right?
Yeah, totally. Well, that makes sense too. I remember Greg always describing it over and over as like it's just a process with a hole knocked in it.
Yeah.
Okay, well, let's just, I guess, get this back to the form that is correct. And then let's just say, like, instead of naming, I'm going to do it the Isaac way. We're just going to call this some channel.
Oh, yeah.
And then we're just going to call this some free variable. And then we'll do like x par. I want to put something here to make it just a little more interesting inside our continuation, but I don't know exactly what it would be. That doesn't make it so interesting it's hard to do. You know, like what else? We could do that, but that doesn't really change anything.
Yeah.
And then I was like, oh, well, let's just try a send real quick, but even sends are super hard to write. Well, maybe not if I do it this way. Chan2 send, no. I guess this thing will basically just sit here and, what if we do that? Now we've maybe got something interesting. I don't even know if this is valid, but I guess we'll just find out. So, okay, this is our example. We'll find out whether it's valid and whether there's any reductions. So in order to make this regular COM kind of reduction, we need three things. We need a send, a receive, and a catalyst. So I see my send, I see my receive, and I see my catalyst. And then we further have to answer the question, are the send and receive on the same channel? And in this case, they are. And so I think that's all we need to have a COM event, right?
Okay, yeah.
Another thing that's striking me as interesting is that we have this relationship between the send and receive. Just like before, they have to be the same channel. Like not every send is compatible with every receive, but we don't have that same kind of restriction for these COM catalysts. You know what I mean? Like this COM cat, like if there were in fact, here's a good example. Here's another context, L. Or maybe we'll call it C. We've got two contexts, K and C. I think we now have a non-deterministic program here, right? Like this could reduce with either one of these COM catalysts.
Yeah, this is a good question. So they are all like candidates that you can choose to reduce.
Yeah. You know, like
there must be a difference between each other that you can say okay or not.
What was that?
They can be different, right? You can build K from different. You can make K like in many different ways.
Totally.
So how you choose the what K you will use for your reduction?
Yeah. So in Greg's like intuitive example, he was talking about like imagine if you have to convert like a TCP packet into an HTTP. I don't even know what the term is, like thing. I mean, if we have those kinds of constraints in mind, I want to use whichever one of these is an adapter from TCP to HTTP, right? If I want P to go somewhere specific, I need to use the right kind of adapter.
And very well, but very will search where the K is, good fit, because you will use K inside the continuation for, right?
Yeah.
So before you are making reduction, you must look at the continuation inside the for and say, okay, this will work with this context. Or
yeah.
Does this make sense?
It totally makes sense. I don't feel like I know the answer or how to solve it. One thought was like, rholang's cool because it has all those non-deterministic aspects, but most of the time when you're writing rholang, what you really want to do is make sure that it's not deterministic, or that it is deterministic, like so that it executes the way you want it to. Maybe that's like the art of being a programmer in this like calculus, like I don't want to put these things all just into the soup because then they'll reduce all, willy-nilly however they want to. I don't really know. I'm just kind of guessing.
Yeah, I'm wondering if you put something in a in a tuple space, your K, and someone else use it for reduction and.
Yeah, that's right. Yeah, that's right. I had this thing composed perfectly, so it was going to reduce the way I want. But there's other stuff in there that snatches up my COM catalyst, and they didn't want it, and I didn't want them to have it. But it's just how it happened.
Yeah. So I'm wondering, you're pushing a hole inside the process, and you're making context, right? And
that's right.
Maybe you want to search for right process that exactly fit in the hole. So
Yeah. So,
but
okay, part of me is wondering now if where's the original reduction? Oh yeah. So I was gonna say, I wonder if it's necessary, like maybe this K here has to be the same K that goes into making this channel, right? The channel's made of a context and a process, but that is very clearly not the case in Greg's example, right? Like his channel was definitely the simplest context, and here he just wrote K prime. Like that's just some arbitrary, you know, specifically not written the same way kind of context. So yeah, I don't know how you. I almost said I don't know how you avoid that problem, but it kind of makes me think maybe it's not a problem, I'm just misunderstanding or something.
But you can you go a little up?
Yeah, totally.
He mentioned this if K prime is of the form,
Oh.
and this K prime is like like a big term, and I didn't go to think about, you know, how this K fits into this example. But is it really that the K is like this giant term?
So, okay, so a simple example shows this, and that's the reduction we just did and talked through. Then he says if K prime, the one I was just mentioning, which is the one from the COM catalyst, if K prime is of this particularly big form, which by the way, this is another just COM event. So this thing also reduces. That's the punchline, right? We can make this is of exactly the same form as we had above. We just have this K double prime. I think the punchline here is like we're composing two of these. Before we make the final substitution, P is going to go into a context, which is going to go into K double prime before it finally goes into the continuation.
Oh, so you're saying, I was thinking that this long expression is another K, not another process.
Yeah, this should be a context, right? Because if K prime is of the form. Yeah. So if in order to be a context, it just needs to, it's a process with a hole knocked in it. So it looks like a process, except here there's a hole knocked in it. These ones don't count. These are not contexts. These are, I mean, they are, but they're packaged up inside a name, so they don't count as things we can sub in for. This is the only free-floating hole in this context.
Oh, I see. And the first four is a process, and it is in par with the K.
Yep.
And it can also be a par with the COM, which is a process.
That's right. That's right.
So this K rule, that this par in K says that we will always have a par and the K, when the process and the K, right?
This one, yeah, this one. That's right. There's no K par K, but there is P par K.
And what does it mean in this example? So we will always have equal number of processes and Ks.
No, it means you'll have 0 or more processes and exactly 1 K.
Oh.
Because, yeah, P obviously has to be a process. K has to be a context, which includes maybe one of these. So if I sub this in for K, then I have P par K, and I can do that a bunch of times and get arbitrarily many P's parred in with, as long as there's one proper context in there, the whole thing is a context.
Cool.
It's surprising to me a little bit that this requires another, like this is a thing that could be reduced. I didn't quite expect that, and I'm not sure quite why. It would be an interesting reduction to try to do, but it would require us to jam this whole thing into the K prime. It just seems too hard to write.
Yeah, I didn't try to.
It almost seems like that we need a nice way to visualize these things so we can like slide them around and.
Yeah, this is exactly, I think, what Greg was explaining. It's his visualization of row calculus, right?
Yeah, I don't know. Isaac followed up on that a lot more than I did.
Yeah.
But
I would like to see this visualization.
Yeah, it's too bad we don't like you know, when that course was going on, we had a nice direct means of asking Greg questions like this, and it's harder to get that now. But I guess maybe Casper stand up is the time to do that. But,
Yeah.
all right.
Well,
Guys, it's 12:30. I got to roll.
The reports are often very short in Casper stand-up, and then the subject goes anywhere.
Yeah, so that would maybe be and this is even like kind of relevant to Casper too, right? That's how we got on it, because he's trying to use it for the liveness proof.
Yeah.
True. Yeah, it's on topic.
Yeah.
Yeah, Jim, you asked a question on the last session, right? Exactly about that. How this how can we think about this in terms of in rholang? How this can be implemented in rholang?
Yeah.
Maybe I have to go back and look at the video.
Yeah. Jim, you also asked the question that I wanted to ask, which is, you know, we're starting to get the idea of error correcting codes. Like on their own, they make a decent amount of sense, but like how exactly does that tie to a time constraint? And Greg gave the answer that I figured was probably the right answer, but it wasn't the one that I wanted him to give. And he said, well, that part's covered in that paper that I referenced. Like,
yeah.
I forget what it's called, error correcting codes and their relation to consensus or distributed agreement, I think. And I was like, yeah, I guess we should read that. I was kind of hoping you'd be able to explain it in 10 minutes, but that's probably not very realistic.
Oh, yeah, exactly. Yeah.
Yeah. So.
Yeah, that paper tended to rely on the results of a lot of other papers, and it's a real black hole of research going off into this stuff.
You've really got to trace down the dependency graph.
Yeah.
Yeah.
I'm hoping Greg is stuck in his own way of describing this, and I understand why he does it. At this from a different discipline, I think, logic and a branch of mathematics that I'm not really all that familiar with. So his explanations aren't always the most helpful to me. So that's why I like to listen to what you guys are saying about this. And I'm expecting somebody from this group to come up with some better ways of explaining what he's thinking of here. But I'm looking forward to going and watching some of those videos. I had forgotten about that session, thinking that it was probably beyond me. But yeah, pointers to tidbits like this are great helps. Thanks, Tomislav.
Oh, no problem.
Well, I'll say, Gary, I watched them all the first time, and pretty much the first third I understood, and after that it was kind of beyond me, like you're saying. But I still let it wash over me and kept watching them, and some of that stuff is starting to make sense now. So it might still be worth watching. Like sometimes I just have to do that, watch stuff that doesn't make sense, and eventually it kind of starts to later.
Yeah. That's what I'm finding with this. A lot of the stuff that was totally beyond me before is starting to make a lot more sense now.
Yeah. Cool.
Yeah.
You guys want to call it there for the day?
Yeah, I need to run.
Yeah.
Cool. All right. Good hanging again, as always. Thanks for those notes, Tomislav. That was really helpful.
Oh, I will put this everything in Discord, but when I finish all the lecture.
Cool. Okay. Cool. All right. Thanks for the room again, Jim, as always.
Yeah, thank you. And we will see you tomorrow, right?
Yeah, totally.
Yeah. Okay.
Bye, everyone.
Bye.